everyone, I'm João from That's Brilliant, and in this video we're going to see some examples of conversion between temperature scales. In the last video we derived an equation we can use to convert between the Celsius, Fahrenheit and Kelvin temperature scales. If you didn't watch the video, I recommend you watch it. I'm going to put the link of that video in the description below. But anyway, we're going to see two main examples. So let me write again that equation that we derived in the last video. So we call the temperature in Celsius of Tc, the temperatures in Fahrenheit of Tf, the temperature in Kelvin of Tk. So we saw that Tc over 5 equals Tf minus 32 over 9 equals Tk minus 273 divided by 5. So if, for example, we want to convert a temperature from Kelvin to Celsius, we do not have to use the side of the Kelvin scale. So you just think about the Tc and the Tf. If you have a number in the Fahrenheit scale and you want to convert it to the Celsius scale, you plug the number into Tf and you solve this equation for Tc. So we're going to see, as I said, two examples. Well, one of them, let's say we have a temperature measured in the Kelvin scale of 303 Kelvin. And you want to know what number represents this temperature in the Fahrenheit scale. So you want to know Tf. You want to convert this number from the Kelvin to the Fahrenheit scale. So we do not have to worry about the Tc right here. We can forget this side of the equation. We are just going to use this this part of the equation. So as I said, you have Tk. You want to know Tf. So just plug Tk, just plug this number into Tk and solve the equation for Tf. So let's do that. As I said, we're not going to use this side right now. You can forget about it for now because we are just worried about Fahrenheit and Kelvin. So we have a number in Kelvin. You want to know Tf, so the variable is going to be Tf. So Tf minus 32 divided by 9 equals Tk. You know Tk. You know it's 303. So 303 minus 273 divided by 5. And you can see you have one equation with one variable, Tf. Just solve it for Tf and you have the temperature in Fahrenheit. So let's do that. You can see here, 303 minus 273, that's 30. 30 divided by 5 is 6. So this side of the equation is 6. We have the Tf, you have that Tf minus 32 over 9 equals 6. As I said, here you have 30 divided by 5, 6. So multiply both sides by 9 and you get that Tf minus 32 equals 9 times 6, 54. And then just add 32 to both sides and you get 86 degrees Fahrenheit. So we have just converted a temperature from the Kelvin to the Fahrenheit scale. So when you measure a temperature and it is 86 degrees Fahrenheit, it is 303 Kelvin. A temperature that in the Kelvin scale is represented by the number 303. This same temperature is represented at the Fahrenheit scale by 86 degrees. So this is the first example. Let's do the second one. So I'm just going to erase it. And we're going to do something that it's quite famous. A lot of people, when they study this is the example, but it's a very cool example. The question is the following. I'm just going to write that equation again. So Tc over 5, Tf minus 32 over 9, and Tk minus 273 over 5. So the question is, what temperature is represented in both the Celsius and the Fahrenheit scale by the same number? The question is, you have a temperature. If you measure this temperature using the Celsius scale and the Fahrenheit scale, the number that the different scales use is going to be the same. So let's just solve this example, and I'm going to explain why that happens after we solve it. So, as I said, we have one temperature that when you measure in Celsius and in the Fahrenheit scales, the number that the different scales use to represent that temperature is the same. So, Celsius and Fahrenheit, we do not need the Kelvin side of the equation. So, thing is, you want to know the temperature that the number of the temperature that is the same in both Celsius and Fahrenheit. You do not have any number to plug into Tc or Tf. But you know something. You know that this temperature is represented by the same number in both scales. So you know that Tc equals Tf. The temperature is the same, and for that temperature, the different scales use the same number. So you know that Tc equals Tf. You can know, you can either call Tc of Tf or Tf of Tc. It doesn't matter. Here I'm just going to choose that I'm going to call both variables of Tc because they are the same. You're just giving a number. You're just giving it a name. So Tc is Tc divided by 5 equals Tf. Tf for that temperature is equal to Tc. So instead, in the place of Tf, you can put Tc. So Tc minus 32 divided by 9. And again, this Tc is just the name of the variable. What Tc is representing is that temperature that we are looking for. So let's just solve this equation. So how can we do it? Just multiply both sides by 5 and both sides by 9. We're going to get that 9Tc equals 5Tc minus, and then 5 times 32, 160. Then it's just a simple equation. You can subtract both sides. You can subtract 5Tc from both sides. So you get 4Tc equals negative 160. Divide both sides by 4, you get that Tc equals negative 40. And what is this negative 40? You can say that 4 degrees Celsius equals 40 degrees Fahrenheit. And I'm going to explain what that happens. If you remember the last video, we saw that the steam point in the Celsius scale is 100 degrees Celsius, and in the Fahrenheit scale is 212 degrees Fahrenheit. The ice point is 0 degrees Celsius and 32 degrees Fahrenheit. We have just seen that 40 degrees Celsius equals 40 degrees Fahrenheit. So 40 degrees Celsius is 40 degrees Fahrenheit. And let's just think about one more number. For example, negative 100 degrees Celsius. So if you have negative 100 degrees Celsius, the value of this temperature in Fahrenheit is negative 148. You can calculate this if you want using the same equation. But what I want to say is, if you take a look from 100 degrees Celsius to 0 degrees Celsius, the Fahrenheit scale changed 180 when the Celsius just changed 100. So you can see that, you can think that way, that the Fahrenheit scale is moving faster than the Celsius scale. So when it's 100, it's 212. When 0, it's already 32. This changed only 100. Just this changed 180. So when here the Celsius changed for 40, and here I missed two negative signs. But when the Celsius scale moved 40 degrees Celsius, the Fahrenheit scale moved 72 degrees Fahrenheit. So you can see that the Fahrenheit scale moves faster. And let's say it's greater than the Celsius scale, and it's moving faster than the Celsius scale. It's going to pass by the Celsius scale and pass and go further than the Celsius scale. So at some time they have to meet, and they meet at the negative 40 degrees. And as I said, it's just, if you imagine, like, let me just grab two pens. Have like two cars, they are moving at different speeds. So there is one that is ahead of the first car, but it is slower. And you have, well, this is going to be so weird, but you have like the car that is ahead of the other one, and it's moving slower. This is faster. At some point, they're going to meet, and then the second car is going to be ahead of the first one. But at some time, they had to meet. And when the Celsius scale and the Fahrenheit scale met, was at negative 40 degrees Celsius. So these are the two examples I wanted to talk about in this video. If I was not clear at some point, please just write a question in the comments below. But this is it. Thank you very much for watching, and I will see you in the next video.